What is going on, everybody, and welcome back to another data science with Python and Pandas tutorial video. In this video, we are going to be kind of building on everything up to this point. We're going to continue with the minimum wage data set for one more video, this one, and kind of combine two other data sets just to see more about this whole relationships thing and learn a few more cool features of Pandas before I finalize this little mini series with doing machine learning, basically a machine learning workflow with Pandas in the next video. With that, let's get into it. So we're going to be using two new data sets here. We're going to be using the 2016 presidential election vote by county, as well as unemployment by county. So pretty cool. So it'd be nice to combine all of these data sets into one major data set and see if voting proclivities, the unemployment rate, and the minimum wage have any relationships with each other, right? Cool. So that's the idea. And really, we're just going to see if there's any relationship. It's pretty hard to, based on that data alone, draw any real conclusions. We're just doing it to see, to learn more about Pandas, really. Really. So if you find yourself offended by the results of this video, not my problem. So anyways, here we go. Import pandas as PD, and then we're going to bring in unemployment county as pd.read_CSV, and that is datasets / and this one is unemployment by county -us / output.csv. So this one came with its own little directory basically. And then we can do unempcounty.head. Okay, and there we get a rate. That's our unemployment rate. And then it's by county and then year. So cool. So now what we want to do is combine this plausibly with our minimum wage. So to do that, we're just going to come over here and basically take all of this data, copy, come over here, paste, boom, awesome. Okay. So now what we want to do is, we still have that missing data, so let's go ahead and fix that real quick. And in fact, can I just do this? Yes, I sure can. No, wait. I actually just want to do this. I don't want the core, I just want to drop it. So instead we'll say act min wage equals act min wage, drop an A, and then act min wage dot head, fix that capital W. Okay, great. So now what do we want to do? So we want to take the minimum wage and we want to kind of add that to a new column in our unemployment county data set. So the way I think I want to do that is by creating a new column and then mapping the values. There's probably a better way than this, but it gives me the opportunity to show you guys at the most basic level a method that will always work for creating new column values in Pandas. This is not the most efficient, and in fact it's going to probably take a moment, probably a minute or two to run. But I'm going to show it anyways because it always works, and then we'll talk about we'll show a couple other examples that are going to be like way faster. But anyway, get. So let's do define get min wage, and this is a function that's going to take two parameters. It's going to take year and by state. So recall, minimum wage is by state, but our unemployment data is by county. Our voting data is also by county. So unfortunately, by county, the minimum wage actually does kind of differ. So right away, we've got a slight violation here. But that's okay. The show must go on, and I'm really just trying to show you guys an example anyways, so whatever. But sure, that's a problem. I don't have minimum wage data by county. So I'm sure there's a file out there that exists. Feel free to use that. If you're trying to make an actual report here, just take note that this isn't quite fair. Anyway, what we want to do, we'll do a try and then except. And if we hit an exception, we're going to return np.nan. Also, we did import it, right? Because we used nan, right? We used nan here. Wait. Everybody just relax a second. When did we never imported NumPy. Not on this one. What? Okay, well, you're gonna need NumPy. I'm in a Twilight Zone. Okay, whatever. Yeah. Okay. I'm still... Okay, whatever. Here we go. Return act min wage, because we just want to get the value, right? So we're trying to get a minimum wage by year and state. So return act min wage. And we can't just say year state, because that act min wage is indexed by year. So actually we're going to do .loc, and then we grab the year. So .loc, .loc year, okay? And then, oh, actually, so it would be year, but no, we're going to say .loc year, okay? As a reference to the index column. And then we want to get that specific state. So that's a function that will do that, and we can quickly test that function by doing something like this, like get min wage 2012 and Colorado. And in fact, 2012 shouldn't be a string. Cool. So that's 8.33, probably impossible to see, but hopefully on your screen you see it. Okay, so now we've got that. Now we're going to map this function to a new column in Pandas. And the way that we can do that is just like a regular mapping function in Python in general. So we can map a function to a list or an array in Python using map. And this is, like I said before, not going to be the most efficient way. But this is a way that will always work, especially when you have things like functions with multiple parameters, or you have a you're not just mapping like one value to another place. Maybe you want to run some sort of true function or calculation or some sort of algorithm, right? You need something more advanced. This is your guy, okay? So this is how you're going to do it. So first of all, I'm going to throw in time just to measure time here. That is a IPython notebook specific command, so don't do that if you're writing PyCharm or something. I don't even know. That might work in PyCharm, but definitely not in idle and Sublime Text. Okay, so we are going to map a new column. So it's unemp county, and we're going to say min wage, or min wage, and that is going to be equal to, I think I'm just going to write map for now. We have to encase this as well, but we're going to say we want to map get min wage. We're going to map that function, and then you just pass all the parameters of that function. So year, what year are we going to map? Unemp county year. And then what's the state? Well, same thing, right? Unemp county state. And actually year is a capital Y year. Okay, so we map that. Unfortunately, I don't think this will work. I'm going to run it just because I'm on fresh pandas and all that, and I'm curious if it does. Did that work? Everybody relax a second. I have to check this now. Unemp county. I didn't think that was going to work because I think like Python, it used to work in Python 2, and then with Python 3 you actually had to do list map. No way that worked. No. You get it. That's hilarious. That's adorable. Okay, so yeah, we do have to okay. So in Python 2 that actually worked. You didn't get a map object. So actually we have to convert this to a list. Oh, that was so exciting. So fast. Okay, so it actually has to be calculated. Here we go. And then, whenever that is done, I just want it to, we could also see when it gets a number, but I'm just going to do unimp county dot head here. Cool. Okay. So again, all that's doing is we're converting it to a list at the very end, because that, you know, with pandas, you can just say a new column is a list of things, and it doesn't matter how you generated that list. It doesn't have to be via Python, or well, it doesn't have to be via Python initially, I guess, but it doesn't have to be via pandas. Okay. But yeah, so this is going to be relatively slow. If you can do a dot map, that's great. Otherwise, a dot apply or something like that. There are some other options for us, and I'll show an option anyway down the line. But once that's done, cool, we are good to go. So the first thing that I would do once that is done is I would just check to see unimp county dot, and in fact, let's just do this, unimp county rate, and then min wage. Whoops, did that capital W again. So don't forget, rate is the unemployment rate. We probably should have changed the name at some point, but that's okay. And then this is minimum wage. And the question is there a relationship there? Do they correlate together? And then the next question would be pretty much the exact same thing, except to see, do they vary together? So covariance. And we are still waiting on that calculation. Oh my gosh, it's taking forever. So probably while we wait on that, we'll just load in the presidential data while we wait. And then if someone knows a quicker way to do a quicker way to map a function with multiple parameters. So it can't just have one parameter. Because I know, yes, there are quicker ways if it just only had one, but what about when it has two parameters? I don't know. The cool thing is, though, that it just knows to map, you know, by row. Like it's still pretty magical, even though it takes a lot of time. Okay, but anyway, we are done. Unimp county head, done. And then here we can see, is there any correlation? So it doesn't look like there is much of a true relationship, but it does look like they actually do vary together pretty significantly. So that's interesting. I guess that would probably suggest that there's other factors at play, and those other factors have a high correlation to these things, but these things between each other don't. That's kind of how I would read into it. I could be totally wrong. I'm just here to teach you guys pandas, not to actually find true answers. So anyway, let's load in the presidential data now. So let's say pres16 equals pd.read CSV, and this would be datasets / pres16 results.csv. Now, pres16.head, and what I get here is county, FIPS, I'm not sure what FIPS is, candidate, ST, which I believe is state, but I don't know for sure what ST stands for. Percent report, that's probably how many places reported. I don't know. Votes, that's, I guess, total vote. Oh, this is how many votes for that person. This is how many votes in total were made. Yeah. And then this is what percentage for which candidate. So as you can see, so for each county and each candidate, we get all this data. But to keep things simple, let's just do Donald Trump, and then the value we're going to track is the percent. So for each county that we find, our question will be so how many people in that county voted for Donald Trump? And we'd like to check correlation and covariance between the unemployment rate and the minimum wage in their relationship with the people voting for Trump. Okay, so let's do that. So how do we do that? Because now we actually need to combine all this data on county and state and then share the percentage vote. So that sounds like a really complex thing that's really hard to jumble in your head to how you might do that, but it's not too hard. Curiously, I think I'll just continue on this. But okay, so what we want to do now is let's just grab, because our unemployment data, unemployment county. We're going to call it 2015 in a second. Unemp county, let's just do a len of unemp county. Right, that's a very big data frame. So I think what I'd like to do is just get the latest unemployment county data, which I believe is February 2015. And yeah, so we can make that much smaller. So I will do the following. So we have unemployment county. So just to make sure, because we're like going to be dealing with so many data sets here, it's going to be easy to get them mixed up. Right, so we have year and month. So now we want to filter this data frame down to just 2015 February. Okay, so how do we do that? So the way that we're going to do that is similar to what we have before, but we need like two things. So now what we're going to say is county underscore 2015 is equal to unemp underscore county. And then this is probably going to be long. So I'm just, actually, I think, am I zoomed out? No, I wasn't. Anyway, this is probably going to be long, so I'll probably have to zoom out. But for now, unemp county, where, and then we have two clauses basically. So we're going to say clause number 1 and, clause number 2. So under what scenarios do we want county 2015? Well, we want it to be the case where this, and then we're going to say year is 2015. And then we also, like, I'm just going to copy this whole thing, that, and then we're going to say month equals February. February. Awesome. Now that we've done that, ooh, I don't know if I accidentally just ran that twice. That shouldn't matter because we're creating a copy. When we do mappings though, it really will screw things up, especially if you replace the current column name. So we got to be pretty careful about running things accidentally multiple times sometimes. Anyway, cool. Mississippi Nan. Didn't we drop the Nans? Okay. I thought we dropped Nans though. Like way up here, right? Didn't we? Or is that rate? Min wage? No. Min wage and maybe county 2015. I guess because we have because we had the unemployment rate but not a minimum wage value for that specific county. I'm not really sure. Well, we're going to keep moving on and see if we hit any further issues. Probably something to dig into, though. Maybe. But I got so much I want to show so far. So we'll continue for now. Cool. Is that okay? Anybody who disagrees, speak up. If I don't hear anything, we'll just continue. So what I'm going to do now is we need to... So our presidential data set has, so like if we do state, let's say pres 16 st dot unique. Okay, so these are our actual states, but they are the 2-letter, now we know, postal code, right? So we need to convert this state to being the postal code rather than the full state name. So how could we do that? Well, turns out up to this point we actually already did that, right? We've already got the postal codes and the state. We've got a dictionary. We can just map it. So let's do that. So what we're going to say is state ab. It will just do state abbreviation for now. pd.read CSV, and we saved it because we're smart cookies, and we did it. And to be honest with you, as I was making this series, I did not plan that. It just came in. It just was super convenient. State ab.csv, and we will read in. Let me just print out state ab.head real quick. And let's just get this the way we want it. So first of all, we're going to say index underscore call equals 0. Great. And then we only care about the postal code. So state abv equals state abv. Don't forget double brackets there before you get screwed and it's a series. That'd be horrible. Okay, great. So cool. So now what we want to do is convert that to a dictionary. So where Alabama maps to AL and so on. So to do that, we're just going to say state abv dict equals state abv. I think first we would say dot to underscore dict. And then, let me just print that real quick. Let's just do state abv dict. Right. So then we'll just say, we convert it to dict, and then we'll say postal code. Boom. Now we've got the dictionary that we can now map to the column. So we can actually just rename that column just right in place. So we can say county 2015 state is equal to county 2015 state dot map, and then we can actually just map the dictionary, and it's just beautiful and magical, and it works. So we map that, and this would be something you would not want to run twice. Yeah. County 2015. Where do we define county 20? Okay, here. So I could run that again. Right. So the reason why we're seeing that is because of county 2015. So we could have actually said unemployment county dot, and we could run a dot copy there, and that should fix our error. I'm too afraid though. I just don't want to have to run everything again. But yeah, that's probably what we would need to do is throw in. Let's just try that really quick. Dot copy. So we throw in the copy, and then let's run all of this again. Cool. Okay. So now, so let's just do county 2015 dot tail. Okay, great. So we have everything there that we need. So everything's been converted. Yeah. So now what we want to do is let's check. So print len county 2015, and then let's check the length of pres 16. Pres 16. Okay, so pres 16 is longer, so let's map that to 2015. Now, let's do pres 16 dot columns real quick. Whoops. So we have a couple of issues here. We want to map these things together. So we're going to merge them together or join. Merge and join on the back end of Pandas are actually the same code. It's just the default is different, but you actually do the exact same operation with either one. So yeah, so you can pretty much interchange those things. But so the first thing to note is how do we want to merge these together? Well, we would merge them based on the year and the state. So, or I'm sorry, not the year and the state. The year is the same because everything is only 1 year. So this is both of these are 1 point in time. So we want to merge them together on state and county. Those are the two different things. So the first thing that we want to do is make sure state and county they're identical between these two data sets, and right now they're not. One is ST, and then the other is county, but it's lowercase c, whereas here it's capital S and full state, and then county. So we have to fix those two things first. So first we're going to say, and in fact, let me make a little more space. So first we're going to say pres16.rename, and then we will rename the following columns. And we're going to do lowercase c county gets renamed to uppercase c county. Simple. And then we want to do state as well. So st maps to capital S state. And then we're going to do this in place equals true. Pres16.head. Great. So state, assuming county here is correct. It's just this state is US, and that's totally fine. No big deal. So now, to join these two things together, what I would like to do is join them, and we can join them on an index. That's the easiest way. So for both of these, we're just going to set the county and state as a double index, basically. So you can have an unlimited number of indexes. All right. So that's what we're going to do first. So we're going to do the same thing for both of these. So we're going to say for df in, and then we're just going to list them, because we're going to run this exact same code with both anyways. So county 2015, and then pres16. What do we want to do? Well, we're going to say df.set underscore index, and we are going to set a dual index. We're going to say county, come on, and whoops. Hopefully it doesn't screw anything up. State, and then in place equals true. Cool. Now, what we want to say is we still haven't filtered pres16 by... So like if we say pres16.head, as again, we still have all of these. So we got Donald Trump, Hillary Clinton, Gary Johnson, and so on. And right now I just want to grab Donald Trump. Later, maybe you'd want to add in all these other ones and just see, like maybe like Gary Johnson's a libertarian, so his relationship to like minimum wage and people who vote for Gary Johnson might be significantly different, because like he would be probably a proponent of no minimum wage, right? And so anyway, maybe you'd want all of these candidates, but for now let's focus purely on Donald Trump. And so that is probably, that will serve for the biggest divide between people, you know, generally between Hillary Clinton and Donald Trump was where the majority of the votes went. So anyway, pres16.head. So the next thing we want to say is, let's just say pres16 is going to be equal to pres16, where pres16 canned is equal to Donald Trump, not just Donald Trump. And then like the only thing we care about at that point is we don't care about any of these other columns except for the percent column, right? So the next thing we're going to say is pres16 equals pres16. And then again, don't forget to make this a true data frame. We are curious only of the percent column. Then pres16.dropNA in place equals true, just to get rid of any mess. And then pres16.head when we're done. Hopefully no errors. Great. Okay, so now we're ready to merge these things together. So to do that, we'll make another data frame all together. And that's going to be equal to county 2015 dot merge, and we are going to merge pres16, and then we're going to merge on equals, and we'll do county and state. You know what I do? Merge county state, and then all together dot drop NA in place equals true. And let's just do that real quick, see where we stand. All together dot head. Let's drop that year column. So all together dot drop, and we are going to drop year. Axes equals 1 because we're trying to drop columns, not rows. And also in place equals true. In place equals true. And then again, all together dot head. I can't type together very fast. Okay, now let's grab the correlation and covariance. So all together dot core, and then all together dot covariance. Okay, So it appears that that these things, like let's say the percentage vote is like with minimum wage, for example, it appears the percentage vote is negatively correlated with minimum wage. So the more people, let's say, as percentage goes up that voted for Trump, minimum wage goes down, or vice versa. So the higher the minimum wage, the less likely we were to vote for Trump. That seems to be the relationship, which kind of makes sense. Like higher minimum wages are a more liberal type issue. So that would make sense that those things are correlated. But curiously enough, they don't appear to vary together. So I'm not really sure how to read into that, to be honest with you. Otherwise, like the unemployment rate doesn't appear to co-vary with who we voted for, and then also doesn't appear really to correlate either. So interesting. It appears that politics are way more complicated than we thought. I guess it's not just simple. Anyway, I think that's enough for pandas. We've done a lot of stuff with pandas. Again, there are so many things that we can actually do with pandas that it would take me forever to show you guys like all of the things that you could plausibly do. Like, for example, we mostly just did stuff with CSVs. We didn't really read from databases or anything like that and use other data files. And there really is like so many things that we can do. But for the most part, I tend to find myself reading in data, kind of reshaping that data in some way, doing basic analysis like describes, and then the next tutorial I'm going to show you guys is the machine learning stuff. So how do you go from a data frame and feed that through an ML model? That's what I'm going to be showing you guys in the next tutorial. With a different data set, we're going to be leaving politics behind. And yeah, so questions, comments, concerns, whatever, feel free to leave them below. Again, any of the findings that we found here are really not statistically significant, even though really the finding was we didn't find anything. So anyway, that's all for now. Yeah, questions, comments, concerns, leave them below, discord.gg/Centex. I will see you guys in the next video.